This is 2023 AMC 10A problem 22. Circles C1 and C2 each have radius 1, and the distance between their centers is 1/2. Circle C3 is the largest circle internally tangent to both C1 and C2. Circle C4 is internally tangent to both C1 and C2 and externally tangent to C3. What is the radius of C4? So I've already marked out all the tangent points. For example, here this is a tangent point. And so first thing we notice is that we can find the radius of C3. How? Because we know that this is the center of C1, right? This is the center of circle C1. And circle C1 has a radius 1 as stated in the question, meaning that this is 1. Now we already know that this part is 1/2, meaning the remaining part is also going to be 1/2. Using the same logic, this is the center of C2, so this must be 1. So we know that this is 1/2. So the diameter of C3 is going to be 1/2 times 3, which is 3/2. So the radius is going to be, so the actual radius is going to be 3/4. So we know that this part is 1/4, and this is also 1/4, so this is the center. Okay, so the reason many people get this problem wrong is not because they don't know how to solve it. They have all the methods, they're doing the right things. It's just that we find the wrong tangent point over here, because it looks very much like there's no two tangent points. There's only one tangent point right here, which is how I got it wrong the first time. But in reality, there's actually two tangent points here. So when you connect, so after you know that this length here is 3/4, you try to connect the tangent points. So like one of the tangent points to, say, this center here, right? And so your goal here is to basically, so you want to find the radius. So let's just say this is the center of C4. You want to find this little segment over here. And what you know is, so you want to find this little segment over here, which is R. And you can connect this and this, so these two segments together. In fact, if you start from the tangent point and you connect this entire line together, this line will pass through both this center and this center, because this is a tangent point for C4 at the circle C1. So this means that we know that this is R, and we know this is also R. So since this is R, the remaining part, which is this really long segment, is 1 minus R. So that is 1 minus R. And we know this is 1/4, and this is 3/4 plus R. So you have the Pythagorean theorem, so you can list out an equation. So basically you can say that R plus 3/4 squared plus 1 minus R squared, plus 1/4 squared, or 1/16, equals 1 minus R squared. So this is just R squared plus plus R squared plus 3/2R plus 9/4 plus 1/16 equals 1 minus 2R plus R squared. You can cancel the R squared from both sides of the equation, and you have 3/2R plus 9/4, plus 37/16 equals 1 minus 2R. So you move the 2R over, you know that 7/2R equals, so something is wrong over here. So essentially, this is 9, so this is not 9/4, this is 9/16. So this is 9/16, meaning that this is actually just 10/16, or 5/8. So 7/2R is 1 minus 5/8, or 3/8, meaning that R is 3/8 times 7, so 2 over 7. So the 2 and 8 cancel out, and we have R is 3 over 28, or D.